people, this is Prof Manqanqa once again. People, remember, subscribe and like and share our YouTube channel. People, let there be light tutorial where we just dish out information, that everything that we know, we're going to lay it out, people, so that it can help and transform people into better students, ultimately in them achieving their dreams. So here, people, this is the second part of the video that I've done, before this one. So I'm still continuing with that part where we're looking on how to find the domain of the functions, people, the domain of any function given. So I've started out with the first three functions, people. All of them, people, these are the types of questions that you'll definitely come across, people. You'll find them because I've studied and tried to really check how these questions are asked and how the types of function that they use. So it's everything. It's out there, people. So this is my second part. So to get sense of things, people, make sure you go straight on our first video to gain the perspectives, people, because here is continuation. It's whereby now I'll be looking to find what, people, I'll be looking to find what, definitely the domain of what, of functions. It's a continuation of the domain of any function. But in this video, people, remember, I'm continuing. I am continuing with what? With where I left on the previous video. So here, people, I'll be looking on the function where they've combined now. The combined functions in a rational way. They've combined function in a rational way. I don't know whether I'm speaking in mathematical sense, but remember, don't stress out. Example will tie things, will really tie things around, people, so that you will really understand what do I mean. So in this case, people, is that we look at in the previous video, we look on how to find the domain of the polynomial function. We look at how to find what, people, the domain of what, of a rational, and how to find the domain of what, of the what is this thing called, radical functions, people. And so now they always like, people, on how to, they always like to trick you now, people, with these ones, with where they combine two functions. Mostly, people, they combine these two functions. They combine what, people? They combine what? Polynomial function, polynomial and radical function. But they do that, people, what? In a rational way. So when I say it's in a relational way, is that, people, in this case, you can have a polynomial function at the top. You can have polynomial function at the top. And then here you have what? A radical function. Or you can have what, people? A radical function. A radical function. And then at the bottom you have what? A polynomial function. So these are what, people? Polynomial function. So these are the two types of combinations that you can always get, people. So remember, people, I'll give you, these are the four types of function you can get. The first one is radical function. The first one is a polynomial function. The second one is a polynomial function. The third one is a radical function. And now I'm here with the fourth one, which is this one. The fourth one is this one. And the fifth one is this one. So to gain understanding on how to find, people, remember the domain of a polynomial, of a radical, of a rational function, please take a look on our previous video. In fact, I'll urge everyone to start today, people, to make sense of this video. This one is a continuation. So these are other combinations, people, that you will come across other than the one that I've named: polynomial, radical, and rational. So it's either you will get this one, these two. So there are 5 of them. That's where they will ask you about the domain and range. And the importance of this topic, people, I cannot ever emphasize, because it helps you to grow function, to draw functions. It also helps you to analyze function, which you will need, people, in every part of your calculus, people, in every unit, in every chapter. So make it a point, people, that you go and watch the previous video, and then this one will definitely make sense. So now let's start with this one. So in this one, people, is that you will have what, people? You will have what? You will have a radical function at the top. No, at the bottom. At the bottom, in this case, it's this one. At the bottom. But remember, you will have what, people? A polynomial function. You will have a polynomial function in this case. Okay? So the example that I'm going to make, it's going to be this one. F is equal to what? Is equal to x squared plus 2x plus 3 divided by this one. So the most important thing here, people, that this one is what, people? This one is our, this is our what? Polynomial function. And then the bottom part is our radical function. And then how do you find the domain of this one, people? This is how you are going to find the domain of this function, people. As long as it is of this nature. The top part is a what? Is a polynomial function, and then the bottom part is a radical function. But remember, with the radical, you must check also. Please refer to the previous video, people, to make sense of this. You must always check whether the radical sign is of the root of maybe even or of a odd. Those are also factors that you're going to take note of. So in this case, this one is of an even number. It's of what? It's of an even number. So here, people, is that there are things that we know. Okay, since this thing is of a rational method, meaning it's written in this way, we know that, okay, the bottom part should never be 0. We know that. It should never be 0. We know that. So this is how you're going to write the domain. The domain, people, is going to be equal to, the domain will be x is an element of what? Real numbers. But the bottom part, the bottom graph, this one, that is on the root side, is that x plus 2 is greater or equal to 0. But don't be too forward, Prof. Mangistu. Don't be too forward. Because this will give you a wrong. This is wrong. It will give you wrong, people. You won't get any mark. Why this thing is wrong, people? This is because when it is equal to 0, the bottom part, people, whole of this thing will be undefined. Will be undefined. So those are the things, people, I wanted to show you there. So this means now the right answer, people, is when it's only when the bottom part is greater than 0. Why it must be greater than 0? Because the root sign, people, is of what? It's of a positive. It's of an even number, 2. So this means it must be greater or equals to 0. But since this radical sign, people, this radical function is under it's under what a division sign, meaning it's a denominator. It must not be equal to 0. That's why I've excluded or I've removed this equal sign. That is why, therefore, it must be greater than 0. Are you with me, people? X is an element of real number, but the bottom part must be greater than. Are you with me, people? But remember, what did I say? I always say you check whether the root sign, people, you check whether the root sign is of a what, people? Whether the root sign is of an even number or an odd number. So let me make an example where the root sign, people, is of maybe an odd number. Because this one is of an even number. Because there is an invisible 2 here, people. So this is an odd number. That's why it must be a whole of this thing that is under square root. That's why it must be what? It must be greater than or equals to 0. But since it's a whole of this thing, people, is a denominator, the 0 is the 0 part is also excluded. It's also left out. So it must be only positive. So it's when x is an element of real numbers such that x or x plus 2, which is the function that you find under the radical sign, which is a denominator, must be greater than 0, not greater or equal to 0 because of the radical sign. It must be greater than 0 because when it's equal to 0, this whole of this thing will be undefined, then you'll be wrong. That's not your domain. So let me make an example whereby now the function below g of x 2x plus 2 over three plus 2 x squared plus 4x plus 4. Remember now, something has changed now. It's a similar function, but something has changed. That this one, the root sign, people, is of what, people? The root sign now is of a what, people? There's 3, meaning it's of a what? It's of an odd. So an odd, remember, an odd, people, it does allow you to take anything that is under 8, people. It does allow you to be negative. So it's a different case now. Hence, in this case now, x will be an element of real numbers, but people, but the only restriction is that whatever that is here, whatever that is below here, people, whatever that is below here, let's call this maybe t. That t, it must not be equal to 0. Because when it's equal to 0, it will make whole of this thing to be equal to 0. And when the denominator is equal to 0, that thing will be undefined. So whole of this thing that is below here must not be equal to 0. Meaning you'll find the values of x where whole of this thing, people, that is found below this radical sign will be 0. And then you exclude those values. Let's say maybe you solve it and then we find that x is equal to 2. This means now, this means that if I want to write this now directly, I'm writing directly the domain of this function, people. X is an element of real numbers, but x must not be equal to 2. Why? Because this thing will be equal to 0. And when it is equal to 0, this thing will be equal to 0, and when this thing is equal to 0, this means this whole of this function will be undefined. Then we're going to be wrong. So that is why, people, I'm doing this. That's why I've done this. So this is just an example, people. I mean? So let's go on. This is just an example, people, an hypothetical example, because I haven't really solved this thing. I don't know whether when you solve it, let me check it with you. When you solve it, which value do we get? don't know when I solve it which value I'm going to get, people. Let me try and solve it. I'm going to take the function that is under square root, people. X squared plus 4x, I'm going to equate it to 0. Let me check whether I can do by inspection. It's going to be 2, it's going to be 2x. Oh, now x is equal to negative 2. Yeah, x is equal to negative 2. Negative 2. So this means now, people, my domain would be x is an element of real numbers, but remember now, x must not be equal to what? Negative 2. Why? Because this negative 2, people, will make whole of this thing that is under a root sign, it will be 0. And when this thing is 0, meaning the radical function, all of it will be equal to 0. And when the radical function is equal to 0, it's like we are dividing this with a 0. And you know, mathematically it doesn't make sense. So it will be antiphon. So that's why we excluded, people. So I hope you enjoy in this case. And then, people, yeah, I hope you enjoy. I've shown you the example. So let's go to the second combination of the function, people, which is where the radical function now is on top. Where the radical function is on top. This one is slightly complicated, people, because it will really need you to really check these things. And then, people, you already need you to really check these things. So let's go on and see, people, how do you really go about it. Remember, in this case, people, in this case is that the radical sign, the radical f is on top, and then is a numerator, and then the polynomial function is what? Is bottom. And then, people, so that's it. So this is how are you going to find this one, people. This is how the example. Let me give out firstly the example. The example, people, will be this one. X plus 1 divided by what, people? Divided by x squared minus 4. So in this case, you must be really careful. What we know with since these people, they must always check whether the root sign is of a polynomial function, or I'm not really whether the root sign is of an even number or an odd number, and then you go about that, how you do go about it. If you don't know, please refer to the video, the first part of this video. So we know we know that this must be what? Must be greater or equal to 0. We know that. And then what else do you know? We know that with this one, the one that is below, we know that this function, it must not be equal to 0, because once it's equal to 0, this does what, people? Whole of this function, which is f, whole of this function f now, it will be undefined because you are dividing with a 0. And then the radical one, people, with the function that is under a square root, or anything that is under a square root, people, in this case, which is a square root, it must be greater or equal to 0. So meaning you must always check, people. Remember, you must always check. What do? You always check the type of radical function you have. Because a radical function, people, it can be of it's of a root of an even number or a root of an odd number. So please distinguish the two. So this is how are you going to find the domain. The domain, people, you're going to find it like this. The domain, people, is that it's going to be x is an element of what? Numbers, but the bottom function, people, the bottom function must not be equal to 0, because when it is equal to 0, this No, I'm making a mistake, people. I'm making a mistake. I'm making a mistake. I'm not really finding the domain here, the domain directly here. I'm making a mistake. So this is not really a domain, people, that I'm finding, but this is what I'm trying to write. The information that is going to help you to write the domain. Meaning it's going to be like this. We know good, okay, the first one is that the bottom function must not be equal to 0. And then the second function, people, which is the radical function, meaning the function under a root f, under a root function under a root, it must be greater or equals to 0. But remember, you always check whether the root, in this case, the root, people, is of a what? It's of an even number, and then it must not be equal to 0. And then your domain, people, will be the interval of these two. The domain will be the intersection of these two intervals, people. These are nuggets, people. These are what? These are nuggets. These are nuggets, people. Because I'm giving you the understanding, the juice. So you're going to check whether you'll be given a function, then you must know. Remember, you have to check whether the radical function is of a what? Is of an even number or is of an odd number, and then you know how to go about. If you're not sure about that, make sure to go back to the first video of this series, people. The first video, meaning the video before this one. You check the type of function that you are given. Then remember, in this case, you are given this one. You're going to say x plus 1, meaning the root sign, the radical function that is here, people, what in a numerator. We must know whatever that is under square root, it must be greater. It must be greater or equal to 0. But another thing that we know with that, we know with it, the function that is under a division sign, meaning our denominator, that function must not be equal to 0 because we'll be dividing by 0. And then, meaning bottom function, this one must not be equal to 0, and then the function that is under a root sign. But remember, a root sign in this case, it's even. It must be greater or equal to 0. So we will determine where the function is not equal to 0, and then we'll determine where the root of an even, in this case it's even, the function of a that is under root, which is the root sign in this case is even, because there is an invisible 2 here. And then it must be greater or equal to 0. And then you find the intersection of these two intervals. And then that intersection of these two intervals will represent will represent your what? You will represent your domain. Will represent your domain. So it's the same thing, people, as this one, where f in this case where g is equal to, maybe, let me say, maybe in this case it's x squared, yes, minus 4. But now things have now changed, that the bottom part, people, is that it's 2x. Okay? Here, people, here, there is no much restriction in this case. So you always check, people, what? You always check whether the root sign, whether it's of, whether n even or n is odd. And then you conclude based on that. And then, people, so in this case, n is odd in this case. So n is odd, meaning it can allow a situation whereby this thing that is under, or this function that is under a root sign, in this case, it can be negative. So it does allow it. So meaning the only restriction here, people, the only restriction is that this function that must not be equal to 0, because all of this will be 0, and when you divide a number or any function, people, or anything with a 0 is undefined. So this means the only restriction is the bottom part must not be equal to 0, so meaning our answer will be x is an element of what? Real numbers, but my 2x function must not be equal to 0, and then you solve. Must not be equal to 0, meaning x is equal to 0 when you solve this. So to write it, x is an element of real numbers, but x must not be equal to 0, because all of this thing will be equal to 0. It will be equal to 0, and if you divide something with a 0, it's undefined. So this means now, people, but as long as this one is a what? As long as this one is a polynomial function, which is mostly the case, people, because usually they don't really go out of scope. So these two videos, people, the first one and this one, people, they give you the solid foundation on how to find the domain. And if you have that knowledge, you know how to find the domain, meaning you can be able to draw function, you can be able to analyze the behavior of the function. And this is powerful because calculus is mostly all about that, people. Mostly about that. So remember, if you are able to find the domain, you can use that information to find and convert that information to what? To find the range, which are y values. So in this case, we are just specifically checking the behavior function on the x-axis. Then you can use that function to use that information to really find any people, to find a range. Because remember, let's say I'm given this, the y, and it's your x. So let's say maybe, for instance, you have your function, maybe maybe this one. So you can see that, okay, and then it ends here, people. The interval, you are given the interval, maybe the interval, maybe here it's 6, and then maybe the interval here, maybe 1, maybe it's -3. Then you're given that the function exists between this range. No, not this range, between this domain of 3 to 6. So you can use this function to find the domain, to find the range, because remember, you check the highest point, of which, people, I'll really help you, people, when you delve deeper with example, because you can take this, you can convert this, people. I'll show you how. Find the maximum value of the minimum value of the function, and find the maximum value of the function, and then you're done, because this will mean that's your range, and then this will be your domain. So your domain, this one. Are you with me? But remember, I'll try to practicalize this thing, people, through questions. With how do you really find the range from domain? So, people, this is not really the last video. The video that will follow, I will do the practical question, whereby I will take this theory and practicalize it so that you can gain that understanding from the practical experience, because I know that sometimes you can't really explain everything through theory or by explaining concept, but you can. There's also some level of knowledge that one can get from applying that knowledge. So, people, please like and share these videos with your friends, and make sure to subscribe also to our YouTube channel, people. This is Prof. Manqoba signing out.